All right, so welcome to section 4.2, where we're going to discuss probability a little bit more in depth, and specifically conditional probability and independence within our probability questions. All right, so in this section, you're going to be able to calculate and interpret conditional probabilities, use the general multiplication rule, which you've probably seen before to calculate probabilities, understand how and when to use tree diagrams to model a chance process, basically to find probabilities, determine if two events are inappropriate, and then use the multiplication rule for independent events to compute probabilities. So I will just say this section is very heavy on the tree diagram. So the better you get at tree diagrams, the easier probability questions are going to be. And also, the more you practice them, the easier they're going to be. So I would highly suggest, if you have the time, to try some of the practice problems below the content section, just to make sure you can recognize what the question is asking and how to answer it. All right, so let's just talk about this word conditional probability. We sort of briefly talked about it in the last section. The probability we assign to an event can change if we know some other event has occurred. So this is key to the idea of many applications of probability. So that's just basically like saying, what's the probability that it's going to rain today versus what's the probability that it's going to rain today knowing that there's clouds in the sky. So there's a condition imposed upon the initial probability. When we're trying to find the probability that one event will happen under the condition that some already event is known to have occurred, this is conditional probability. So like I said, conditional probability just means that we know something else has already occurred. Is that going to change the event of our probability? So knowing that we are a high school graduate, does that change the probability of whether or not we own a home? So we're imposing the condition, we know that they're a high school graduate. That's conditional probability. So suppose we know that event A has happened. So suppose we know that they are a high school graduate. Then the probability that event B happens, find the probability that they're a homeowner given knowing that they're a high school graduate. So the probability that event B happens given A that has happened is denoted by this probability symbol here. P, probability B given A. So B, this slash mark means given A. So this is saying that A has already occurred. Knowing that they're a high school graduate, what is the probability that they own a home? So finding the probability of B given that A has already occurred. Okay, so just make sure you understand that that's read as given that or under the condition that A has occurred. All right, so let's go back to that high school graduate homeowner question. Here's the two-way table from the example. So if we know that the person owns a home, we're only looking at the total to be the homeowner. So let's say the condition is given that they're a homeowner, we are only looking the total of homeowners of 340. That basically means we're crossing out everybody else. We're not looking at the total of 500. We're not looking at anybody that's not a homeowner. There's a total of 340 people in the sample that own a home. Because there are 221 high school graduates among the 340 homeowners, the probability that they're a high school graduate given that they own a home is 221 out of 340. So that would be A given B. Given that they own a home means I'm only looking at the homeowner, so that changes my denominator to 340 instead of the 500. Okay? Here's what it would look like in symbols. G given H. All right, so if we know that as a person is a high school graduate, we ignored anything that's not a high school graduate. High school graduate is now our denominator. What's the probability that the person owns a home? Because there were a total of 310 people who were high school graduates, and 221 homeowners among those 310 high school graduates, the probability was, probability that they own a home given they're a high school graduate. So basically since we know they're a high school graduate, we're crossing out everybody that's not a high school graduate, and now we're just looking at the total of high school graduates, which is 310. Owns a home, given it's a high school graduate, the new denominator is now 310 because there's only 310 that are high school graduates. 220 one of those own a home. Okay, so in symbols, this would be H given G. Find the probability that they're homeowners given that they're a high school graduate. So I'm just looking at the high school graduate problem or column, and I'm basically imposing the condition, okay, conditional probability that they are a high school graduate. It's already known that they're a high school graduate. Just make sure that you show this fraction right here and then your decimal answer. All right, so let's take a look at a couple of how we actually got this probability. There's two ways to do this. One is just from the table, which is easier to do because we have the numbers right in front of us, but it's not always going to be that easy. I'm not just going to necessarily have the numbers in a nice little table to find the answer. So let's just derive a formula on which we can use this in any given situation. What's the probability that they own a home given that they're a graduate? Now, look at your denominator. Your numerator was the probability that they were homeowners and they were graduates. All right, so that was the intersection. The numerator, the 221, was both of those occurring at the same time. Then the denominator consisted of the fact that they were a high school graduate, just the 310. Now, what if we write this as a probability statement instead of just numbers from the table 221 out of 310? Okay, how could we do that? The probability that they own a home, given that they're a high school graduate, is the same as the probability statement. Now think about the top right here is the probability that they are homeowners and graduate. That's where my 221 came from. So what is the probability that they're a homeowner and a graduate? And the denominator was the fact that they were a high school graduate. So what's the probability that they were a graduate? Okay, that's what's given to you. That's the condition. So if we're strictly looking at the probabilities and not just the numbers from the table, we're still going to get the same answer. So you're taking a look at each of these two probabilities and assuming that there's no conditions on them. The probability that they're a homeowner and a graduate, there's the intersection 221 out of 500, all right, given that the probability that they were a graduate is 310 out of that 500. Now if we rearrange these, do our keep, change, flip back from, I don't know, when you learned multiplication of fractions, these 500s basically cancel out and you get 221 out of 310, which is the same answer. So this is the same answer we arrived at. All right, we just use the probability statements here instead of just the straight up numbers. This probability is going to lead us to a general formula for computing conditional probability. All right, so let's think about what we did. When we did the homeowners, the probability of A given B, we looked at the intersection of the probabilities over the probability of what was given, over the condition that was imposed. All right, this is the exact same formula that we talked about on the previous page. So A given B is the probability of A and B both occurring divided by the probability of what we already have known to occur, which is our condition. So the conditional probability of B given A is the following. Okay, so same thing, B given A. Now this time we know that A has occurred. All right, so you don't necessarily have to memorize the B given A, where's the A and B go. Just know that the numerator is always the probability that they both occur, the and statement. The denominator is the probability that the condition has occurred. Okay, so what you already know has occurred is in your denominator. All right, so what we see on the AP exam formula sheet, here's what you'll see, but honestly, just make sure you can interpret that this is A given B. The numerator is always the probability of both occurring, and the denominator is the probability that your condition occurs, okay, of what you already know. What you already know is in the denominator. All right, so what work are you going to need to show? And in the next couple of section or slides, we're going to be looking at using tree diagrams and conditional probabilities. And with tree diagrams, we're going to be having decimals. So you still need to show the probability statement, A given B, and what the numbers are you plugged into the numerator and denominator, even if they're decimals. So if this is a decimal and this is a decimal, I know that's yucky math, but show those plugged in and then show your decimal answer. If you don't show that fraction, you will not get full credit. Now, it doesn't matter which formula you use, A given B, B given A. No, it doesn't matter. All that matters is you know that the numerator is the probability that the events occur together, okay, over the probability that the given events occur. So over the probability of the condition, the one that we already know has occurred. And the most common mistake I would say is just making sure that the given portion is in the denominator. So sometimes people put the a in the denominator, but just make sure. So sort of think of it this way. This is kind of like a fraction a given b. All right, so it's like divided by b, so divided by b also needs to be on the bottom. All right, so let's just take a look at an example. The students at the University of New Haven, New Harmony, received 10,000 course grades last semester. This two-way table breaks down these grades by which school of the university they taught. So we have a liberal arts school, engineering and physical sciences, and health and human services. So E, now when you do this, when you use L, E, and not writing out the probabilities, you have to make sure you define what E, L, G, H, whatever represents, or else you can't use the symbols. All right, E is that the grade comes from engineering and physical science. L is that the grade is lower than a B. So find the probability of L. So that's just basically saying the probability that the grade is lower than a B. All right, so now I said, remember, before you do any of these questions, always find your totals. It's going to make your life so much easier. So the grade is lower than a B. That's right here, divided by your total of 10,000. Okay, now for the second question, find the probability E given L. The fact that the grade comes in from an engineering course, given that the grade is lower than a B. So since we know that the grade is lower than a B, that's our denominator. That's what we're looking at right here, because we don't care about anybody else, all right? We don't care about the A's and the B's. So given that they're lower than a B, that's the bottom portion. What's the probability they're from the engineering and physical sciences? That's the green portion in 800. How about L given E? What's the probability that their grade is lower than a B, given that they're from the engineering and physical sciences? So we now know our condition is engineering and physical sciences. That's the only total I want to look at is the 1600. Okay, and I want to find the probability that it's lower than a B, so 800 out of 1600. All right, so what exactly do the probabilities tell us? College graduates tend to be lower in engineering, okay, if you take a look at the grades, and the physical sciences than in the liberal arts and social sciences, which includes health and human services. I'm sure you've heard that, biology majors, engineering majors usually have lower grades than everybody else, and, people argue that their classes are harder. Which of the conditional probabilities tells you whether the college's EPS students, engineering and physical science students, tend to earn lower grades than the students in liberal arts and social sciences? So how could you write the probability, compare the probabilities that the engineering and physical sciences students have lower grades than the students in liberal arts and social sciences? And just take a minute and think about that before we take a look at our answer. All right, so let's just take a minute and look at those probabilities. So what is the probability that the grade is from an engineering and physical sciences given that the grade is lower than a B? So basically we're taking the column and looking at everything lower than a B and comparing the liberal arts, the engineering and physical sciences, and the health and human services to see which of the three has the largest proportion or probability that has the grades below a B. All right, so conditional probabilities allow us to sort of compare within groups instead of comparing to the total. So grade is from EPS given that the grade is lower than a B. So 800, so 21% of the grades lower than a B are engineering and physical sciences. What is the difference that it's lower than a B given that they're from engineering and physical sciences? So now we're changing here. Knowing that they're from engineering and physical sciences, that's going to be my total right here, okay? Grade from engineering and physical sciences, that's the given. What is the fact that they're lower than a B? So that's 800, lower than a B, out of the total of 1600. So 50% of the grades from engineering and physical sciences are lower than a B. That's pretty, that's pretty low. So the probability lower than a B, given that they're from engineering and physical sciences, gives the probability of getting a lower grade given that the student is studying engineering or physical sciences. Because this probability 0.5 is greater than the probability of just the liberal arts, we can conclude that the grades are lower in engineering and in physical sciences. All right, so let's just go back to this. In the last section, I think we talked about